Order of operations, part 2. Remember from earlier in the semester, the order of operations are rules that we use to clarify the procedures that should be performed first in a given mathematical expression. And when we have more than one operation, we have to follow these agreed upon rules for the order so that we all end up with the same values when we calculate. And the rules, as you should recall, are PEMDAS, PEMDAS, or please excuse my dear Aunt Sally. And remember, P stands for all the grouping symbols. We have parentheses, square brackets, set notation, also have absolute values. They all group together and they come first. And then next do any exponents or radicals, and that means simplify what's underneath the radical first, and then do the square root, or simplify what's inside the parentheses for an exponent, and then take the exponent of the parenthesis part. MD, those go together, and remember you work from left to right. If you hit division first, before you hit a multiply, you do the division first. Same thing for add and subtract, work left to right, whichever you come to first has precedence over the ones following. And if you have a division bar, you start with the numerator and simplify it, simplify the denominator as much as you can, and then at that point you look to see if there's anything you can simplify for the entire expression. So let's look at the order of operations with some radicals. So we want to simplify this expression. It's just one single radical, so I'm thinking, okay, I've got to handle everything under the radical first. But once I'm underneath the radical, I'm looking at all these operations and I see first I have an exponent. So that's going to have to come first. And then right here is a multiply. It's implied, and here's another implied multiply. And we really could rewrite this one time and it might help you, so I'll do that. 2 squared, and then we could think of it as plus a -4 times a -3 times a -5. If you look at it that way, you might do better with the signs. So I'm going to show you that way, of course. So first, again, I'll want to handle the exponent. And then second, I'll handle the multiplication. And third, the next multiplication. And then fourth, the addition, because that comes at the very end of our order of operations. So I can look at it 2 squared, that's going to give me 4, and then plus, now I've already handled the exponent, so I'm free to go ahead and look at that next multiply because it didn't involve the exponent at all. So -4 times -3, that will give me a +12, so I can just write it as 12, and then I still have a -5 left to multiply. One more step down, I have 4. Nothing I can do there yet. Plus, well, let's leave that off for a minute. So I have +12 times a -5. So that's a -60. And then now I can finally handle that subtraction. So I have the square root of -56. And now remember, with the square root of a negative, we want to pull the negative out front. So we're going to make it the square root of -1 times the square root of 56, and that is equivalent to I, and the square root of 56, we're wondering, do we have any perfect squares in there? So I'm thinking 8 times 7 is 56, 8 is 2 times 4, 4 is 2 times 2, and 7 is prime. So all my list on the denominator, or on the radical, all the factors that are being multiplied, I'm showing there in blue. In there I have a pair of 2's, I have a leftover 2, and a leftover 7. So the 2 I know I can rewrite here, get back to my red pen, it's going to be the square root of 2 squared times the square root of 2 times 7. So square root of 2 squared, or the square root of 4, is going to come to 2, and the square root of 2 times 7 is going to be the square root of 14. So I have 2 square roots of 14. And remember, I also had an I, so it's going to be times 2 square root of 14. And to write that in a better order would be 2i square root of 14. Now, to convert this one into its equivalent form in a decimal, I need to multiply the 2 times the square root of 14, so I'm going to change the order slightly. It'll be 2 times the square root of 14, and then I'll write it as times I. So to do that, I'll put 14 in on the calculator, take the square root of it, and then times 2 equals, and I have 7.483 I, and that's an approximation, so I'm going to put it with the approximately equals, and I'm rounding 1, 2, 3 to the 3 there, and the following number is a 3, so I'm going to leave it as a 3 in my rounded form. Next one, I'm looking at very complex, and that's the quadratic formula with all the values plugged into it. So let's take a look at how we handle that. First thing, remember, I'm going to have to handle parentheses. And as I look at all these parentheses, I'm looking inside for operations that I have to do, and there aren't any. It's just a number. So I realized very quickly, oh, the parentheses are just there to show me to multiply. So they're going to be handled when I handle multiply. So then I'm looking at the next thing, and I've got a square root there, and I have an exponent there. So I need to handle everything under the square root first, and under the square root I do have an exponent, so that has to get handled first, or as soon as I'm looking at that square root, which is also first. So let's write it. 9, this is plus or minus, remember, and then square root. 9 squared, that's my very first operation, so I get 81. And then remember, I can think of it as plus a negative 4 times a positive 2 times a negative 3. And that might help me keep my order straight and my sign straight. In the denominator, remember, you can work the numerator and denominator separately, so I can look at the denominator and think about, oh, it's just got to multiply, let's handle it, and that's a 4. And then now still looking at my numerator in the square root, because that's the next thing I have to handle. I see 81 plus, so I don't want to do that yet, and then I see 2 multiply, so I want to handle them next. So I'm going to put those, they are next. And then right after it, I'll do the second one. So I have negative 4 times 2, and that gives me negative 8 times negative 3, that gives me positive 24. So I check my signs again. Negative times positive is negative, times another negative is positive. So I got the signs right. So it should be 9 plus or minus square root 81 plus 24, we decided, all over 4. Now I'm down to just addition under the square root. So I can handle the addition. I still haven't done anything outside other than multiply that 2 times 2. So I have 81 plus 24, so it's 105, 105 over 4. And now I want to look at that square root, and I want to see, can I simplify that square root? Just like we did on the last example, I want to look at the square root of 105 and see. It is divisible by 5 because it ends in a 5, so I want to take 105 divided by 5, and I get 21, so I have 5 times 21, and 21 I know is 3 times 7. And this is a case where we don't have any squares that are factors of our radicand. I have 5 times 3 times 7. There's no pairs, so I can't simplify the 105 at all. So when I come back here, my answer is what I have written. There's nothing further I can simplify. Make my square root look just a slight bit smaller. There's nothing further I can simplify. Now, remember, though, that when I go to make my decimal equivalent, that I have one expression that is 9 plus the square root of 105, over 4, and one that is 9 minus the square root of 105 over 4. So I have to work out both of those and get two separate decimal equivalents. The square root of 105 has to be done first, and then adding the 9 to that, and then take that whole sum divided by the 4. And I'm going to have to use the square root of 105 in both problems here, so I'm going to show you how to store that on your calculator so you don't have to recalculate it. First thing I want to do is type in the 105 and then push the square root button, which is right there. And then this is the number I want to use in two different calculations, so I want to store it. I have a store button here, and for this calculator I push store, and then I have to choose one of the numbers for a bin for where I'm storing that number. So I'll want to store it in 1 just so I don't forget, and then it's there. It doesn't tell you anything different, but it's stored it in 1 for you now. And now I'm going to start over on my calculation here. I need 9 plus, so 9 plus, and then I want to pull that square root of 105 out of my storage bin, so I'll do recall bin 1 because that's where it was, and there, if you remember, that was the square root of 105. So I push equals, I get 19.2. So now divide by 4, that's the next thing on my list there, and I have 4.8117, and since I want to round to 3 decimal places, it's that 1 right there. I have to look at the 7. That's going to bump it up to a 2 instead of a 1. So now it'll be 4.812. So that'll be my 3 decimal approximation. 4.812. There's one of my two answers. Now I can't just take that 4.812 and slap a negative on it and say that that's what I'm getting for my other answer, because it's really not what it's going to come out to. So let's start at the beginning and try it again. So I have 9 minus this time. I wanted to do that square root of 105, so I can just do recall bin 1, and there it is, the square root of 105 equals, and then I have a negative number and I can divide by 4, and equals again, I get negative 0.3117. So again, I'm rounding to that third decimal place, and I will have I have a 1 there, but the next digit is a 7. So since it's 5 or greater, it's going to bump me up. So it's going to be negative 0.312. So my other answer, as you can see, is not the same as my previous negative 0.312. And that is my decimal equivalent or approximation for the answer. Number 3. 8 plus or minus square root of negative 64 over 2. So I see I have a radical and it is going to give me an I, or a complex number. So let's take a look at that right away. Square root of negative 64. I know that's going to be the square root of negative 1 times square root of 64. I know 64 is a perfect square, and it is 8 times 8. So I can also think of it as square root of negative 1 times square root of 8 squared. And then that gives me 8i. So I can rewrite that term. So I'm going to have 8 plus or minus 8i over 2. Now if I want to reduce this fraction, because I'm down to just some numbers and I can see that they're all divisible by 2, here's how I can handle it. I can rewrite it broken apart, so I'll have 8 over 2 plus or minus 8i over 2. So I basically separated them out. Think of it in terms of this part here. If I go ahead and combine those, I have two fractions. They have the same denominators. If I combine them, I'll have 8 plus or minus 8i over 2. So it's equivalent to go the other direction as well. So now I want to reduce. 2 goes into 8 4 times, 2 goes into 8 4 times. And I'm left with 4 plus or minus 4i. And that's in its most simplified form. I need to break it into the two separate expressions that it's telling you it's equal to. One of them is 4 plus 4i, and the other is 4 minus 4i. And there's nothing else I can do since they're already in an equivalent decimal form.